Yeah, John.
22 divided by 7.
22 divided by 7? Close. Yeah, I mean, it works. But where does pi come from? It definitely has to do with the diameter and the circumference. In fact, what's down below? Pi is actually a ratio that exists in all circles. So there's tons of different formulas to get pi. It is the ratio of your circumference to the what? To the diameter. Yep. So if you take any circle in the real world and you measure its diameter and its circumference, if you go circumference divided by diameter, you're going to get up pi. You're going to end up with 3.14 for every circle that exists in our known universe. If you find the diameter and the circumference, you actually can use that ratio to get pi. Yes?
Can you do any two numbers, or do they have to make sense?
They have to make sense. It has to be a real circle that has a circumference and a diameter. So you can't say a circle has a circumference of 2 and a diameter of 100. Mm-hmm. Like, that's not going to work because that's not a real circle. So it has to be a real circle. But if you take like a can of soda and you would take a string and you'd measure your circumference and you'd find the diameter of that can, if you do that division, you're going to get 3.14 out. Probably at 3.14 because you're not super accurate measurements. All right, but that is our ratio of our circumference to diameter. So let's talk about circumference first. Circumference is going to be the measure of the outside or the ring of our circle. So that is our circumference. It is a distance. It is a measure. It is a length. Circumference is the length of that circle all the way around. So this right here is our circumference, if I could get that measure. It's going to be something like 29 inches, 44 inches. It is not a degree measurement. It is an actual distance type measurement or length. All right, diameter. Diameter is a chord that goes through the center of the circle. This is my diameter. But whenever you talk about diameter, it goes hand in hand with a radius. Radius is half of your diameter. So diameter equals 2 times r, or you could think of it as r equals diameter divided by 2. All right, who remembers the circumference of a circle? Yeah. 2 pi r. Perfect. So circumference equals 2 pi r. How could I say that if I just wanted to use diameter instead of radius? Let's say I know the diameter is 10 and I don't want to even go to the radius. It'll be pi d. I already said this. I said that right up here. I said pi is the ratio of circumference to diameter. So pi equals circumference divided by d. Well, that's the exact same formula that's right here. This is the exact same formula I spoke about right up here. Because if I just divided both sides by diameter, we'd have circumference divided by diameter equals pi for any circle. All right, what's the area of a circle? Sangha? Pi r squared. The way I kind of remember area versus, because you always have both of these kind of floating in your head. You have 2 pi r and you have pi r squared, always floating through your head. I always remember pi r squared as being my radius because we square things, right? We end up with like inches squared. We end up with like centimeters squared. So when we're talking about area, I'm going to have pi r squared, centimeters squared. The square stays with it. All right, that's what helps me remember its area because we're squaring something. All right, so that is our circumference with diameter, and area with radius. Slightly less helpful is kind of this little guide. It helps some people. I'm looking for my circumference. If I know the radius, I'm going to use 2 pi r. If I just know the diameter, I'm going to use pi times d. Then we switch gears and we go to area. Well, if I'm looking for area and I know the radius, we're going to use pi r squared like we have above. But if I have the diameter, you have to remember to get to your radius, you have to divide by 2. So this would be pi times diameter divided by 2 squared. I almost never talk about this formula d divided by 2r because you usually just find your radius first and then you plug it into your pi r squared. All right, let's just do a couple practice problems. Our first one says, what is the area of and circumference of a circle with radius 10? So that means for our area and circumference formulas, I'm going to use my r. So we need to find our circumference. We need to find our area. Well, our circumference is going to be 2 pi r. Our area is going to be pi r squared. And the information I know is the radius is 10. So for circumference, we're going to have 2 pi times 10. We're going to want to leave pi in all these answers. So we're just going to do 2 times 10, which would give me 20 pi. Down here, we're going to have pi times 10 squared. Well, 10 squared is 100, and we're always going to move that number out front, so we're going to end up with 100 pi. So area is 100 pi. My circumference is 20 pi. Sangha. Like for unit, if we have a unit, yeah, then we'll go unit squared. So if it said centimeters, I go centimeter squared. If you want to keep that habit of just putting unit squared after it, you can. Labib.
So we never put pi in a number, we just keep this symbol?
We're going to keep the symbol, yes. So when you're dealing with circles, almost all your answers are going to have pi in it. Try not to forget. If all of a sudden your answer doesn't have pi in it, just check to see if it actually canceled out or you just forgot to use it. All right, it's a good thing because people are going to forget pi all the time. Yeah.
You don't want the exact.
I don't want, this is the exact.
Like you don't want a decimal.
I don't want the approximation
For everything.
for everything that has pi in it. Yeah, I'd rather have pi in it. Because pi I can work with. As soon as you put the approximation, now we're dealing with decimals and it makes our problems a lot harder. Right? 100 pi is a lot easier than 100 times 3.14159, even if we round there. A lot easier to write. So yes, we're going to leave everything in pi's. All right, what is the diameter of a circle with circumference 16 pi? So we're talking about circumference, we're talking about diameter. So our equation that deals with that is, well, circumference equals 2 pi r, but that's with radius. Labib?
Pi d.
I'm going to use pi d, which equals pi times diameter. All right, so that's the one I'm going to use. So I'm going to go, okay, my circumference is 16 pi. I don't know the diameter, so we're going to have pi times d. Now, don't forget, pi is a number. What you do with numbers, you're going to do with pi. So if I had 16 times 3 equals 3 times d, to get d alone, I would divide by 3. Well, pi is just a number, so I can divide by pi. So we're going to divide both sides by pi. Well, anything over itself is just 1. So pi divided by pi is just going to turn to 1. Pi divided by pi just turns to 1, so I'm just left with 16 equals the diameter. In other words, diameter equals 16. Now, it does say centimeters, so I'm going to put 16 centimeters. This is one of those cases where I'm like, I don't have pi in the answer, but it makes sense because all the pi's canceled out. So I didn't forget pi. I saw them cancel out, so 16 centimeters is my correct answer. All right, that's circumference and area. The only thing we're going to cover next is just what happens if I'm not talking about the entire circle. What if I'm talking about just part of the circle? I want to know this one specific area of the circle. I want to figure out one particular part of the circumference, and that's what we're going to lead to here. So the title of this is just arc length. This is the most important part over here, but I'm kind of shoehorning area into this as well. We're not going to have any problems with area until a little while from now, but we'll get to that. And let's talk about what arc length means. Arc length is a very specific term for part of a circumference. So we know a circumference of a circle is the length all the way around the circle. Well, circumference is actually arc length of the entire circle. So arc length is dealing with circumference. It's dealing with the length around the circle. Now we use arc length particularly because circumference means your entire circle. Arc length doesn't have to be your entire circle. In fact, if we look at this question here, it says find the area and circumference of the shaded region. Well, when I'm asking for a circumference of part of a circle, what I'm actually asking for is the arc length. A more appropriate term for this would be arc length. What is the length of the arc? Now note, arc length is not going to be a degree. That is, I'll say, the degree measure of an arc. Arc length is, I want like 16 centimeters. I want a number attached to it. All right, so the first thing we need to do when we're looking for part of a circle is we do want to find that degree measure of the arc. First of all, just eyeballing, how much of the circle is taken up by the shaded region? A quarter. Let's prove it's a quarter. All right, look at the arc that's being subtended by this angle. That angle is 90 degrees. So what is the degree measure of this arc? Yeah, is 90 degrees as well. That's important. So from here to here is 90 degrees. Now, why that's important is because I know how many degrees are in a circle. There are 360 degrees in a circle. So if I wanted to get basically the percent of how much circle is being taken up, I would go, okay, 90 divided by 360. Well, that's going to equal 1/4. We thought it was a quarter. We just proved it's a quarter of the circle. Now, that's important because not every single time you're going to look at it and go, oh, that's a quarter. Because sometimes it's going to be 22.5% of the circle, or it might be 12% of the circle, and you just can't see it. So you need to know your degree of your arc divided by 360 is basically the percent of the circle you're talking about. All right, so we're at a quarter. We're at a quarter. So we're going to do this a little different than normal. We're going to first come up with the total circumference and the total area. So our total circumference. Remember, circumference is 2 pi r, so it'd be 2 pi times the radius. Well, it says the radius is 10. So our total circumference would be 20 pi. Our total area would be pi r squared, so that'd be pi times 10 squared, which equals 100 pi. Now, who can use their gut instincts to tell me how I'm going to calculate the shaded section? Just the shaded section. Yes?
Divide each by 4.
Divide each by 4 or multiply by 1/4, right? That's exactly what we're going to do. To get our shaded region, we're going to take our total, multiply by a quarter, because I just want a quarter of it. If my total circumference is 20 pi and I want a quarter of it, I'm just going to multiply by a quarter. So our circumference or arc length is going to equal 1/4. That's the 2. That's 1/4 of that 20 pi. And a quarter of 20 is going to be 5 pi. So that is my arc length. All right, the next thing I do is the area of it. Well, once again, we're just going to use 1/4 times that 100 pi equals 25 pi. Did all those steps, at least instinctually, make sense, what we did? Calculate how much percent of the circle I'm talking about, multiply our total by that. Well, that leads us to our arc length formula. The length of any arc is going to equal, what is the degree measure of that arc? So this one was 90. So I did 90 divided by 360, and then we multiply it by 2 pi r. And that's going to be the arc length of that one little section. That is that length of that one little section we're talking about. All right, I'm going to make a slight adjustment to the first problem. The first problem says, what is the length of BC? I'm going to make it BD. We don't need to have a super complicated problem right off the bat. We're going to go arc length of BD. I'll make it a little easier. All right, so let's draw what's happening. So we have circle A. And it has an inscribed angle of BCD. Remember, an inscribed angle goes to the back of the circle and comes out like that. Since it's angle BCD, C must be our vertex. So this might be B, and this might be D. And this is 36 degrees. All right, we need two things. In order to come up with our arc length of section BD, I need to know the radius. Check, we got a radius of 24. I also need the degree measure of the arc. I don't have that yet. Can someone tell me what is the degree measure of that arc, EJ?
72.
It would be 72. It's 36 times 2. Remember, to go from here to here, we have to multiply by 2 times 2 is going to equal 72 degrees. That's everything we need. That means our arc length is going to equal our degree of our arc, 72 divided by 360. We're going to multiply that by 2 pi r. Our r is 24. Remember, arc length deals with circumference. That's why we used our circumference there. 2 pi r is our circumference. Maybe I should have put that on here. Just a quick reminder, I forgot to write that on there, that 2 pi r just comes from our circumference. All right, be careful here, because multiplying this, I want pi as the answer. So the only thing you're going to multiply are 24 times 2 times 72 divided by 36. Make sure with your calculators that you are doing things properly using parentheses. So if you're trying to write the whole thing together, make sure you have parentheses around 72 and 360 so you don't accidentally multiply the wrong stuff. So if I was typing this whole thing in my calculator, I'd do parentheses, 72 divided by 36, close parentheses, times 2 times 24. Can someone tell me what that comes out to? Labib. 9.6. What was you ended with? Pi. Yep. Don't forget about the pi. It's almost pi day. You can't forget about the pi. And it does say centimeters, so we're going to say centimeters. I'm actually going to put that in there. Don't forget. Don't forget. If your answers don't have pi in it, ask yourself, should it have pi? Did pi's cancel out? This one should, and so I have pi in it. Our next one says in circle G, M measure of JR equals 108 degrees, and the length of JR equals 9 pi centimeters. What is the radius? So real quick, let's see what's happening here. So I have a circle. I have a J somewhere on that circle. I have an R somewhere on that circle. It says to get from J to R, you have to turn 108 degrees. But it also gives you a distance of 9 pi. So not only is it 108 degrees, it's also 9 pi centimeters long. Well, our arc length formula is basically our arc is going to equal our x degrees divided by 360 times 2 pi r.
Don't we know what the...
Yep.
Oh,
So now I'm going to fill in what I know. I know what the arc length is. I know that is 9 pi. So that's going to be 9 pi is going to equal, I also know the degree measure. That's 180 divided by 360. What was that? Oh, 108, yeah. 108 would have made it way too easy, right? Maybe 108 degrees divided by 360 times 2 pi r. So what I would do in this case, there's multiple ways to solve for r. We just need to get r by itself. Note that your pi's are going to cancel out. Your pi's are going to cancel out. So in your head, you should be thinking like this, that, okay, I would divide by pi from both sides. The pi's would cancel out. And I'd be left with 9 equals, well, that'd be 108 divided by 360 times 2, which would be 0.6 r. Well, now we just divide both sides by 0.6. Divide by 0.6. And you should come up with your radius equaling 15 centimeters. Questions on anything we covered today? Really, we just did circumference and area, and then we said, hey, if I'm just doing part of a circle, multiply whatever you get by that percent of that circle. So in example 2a, it was 72 divided by 360. That's how much the circle is covered. And another one, we just had to use the fact that we knew it was 108 degrees and the length. All right, real quick, I do want to go over two of the problems. Well, just really one. I'm going to look at number 13. It looks like a long problem, but it's actually asking you one thing. The first sentence is the total question. It says, what is the measure of the angle formed by the hands of a clock at 10:20? Everything after that is what I'm going to talk about right now. First of all, that is not 180 degrees. Let's think about why you might think it's 180 degrees. So at 10:20, your small hand's at 10. Your long hand is at the 20. That looks like 180 degrees, right? But here's the thing. What is your hour hand doing the entire time your minute hand's going around? Is it staying put? No. In fact, let's look at this clock that hasn't jumped ahead yet. We're at 42-ish. We're at 9:42. Is my small hand pointed right at the 9? No. It's going to continuously move closer and closer to the other one. So at 10:20, your small hand isn't at 10. It's actually somewhere between 10 and 11. You need to figure that out. So it's going to be less than 180 degrees. Both 13 and 14, I tried my best to show all of my work down. So my advice to you is if you're really struggling, look at the answer key, determine how I did it, and then tomorrow come with specific questions. Just don't go, I didn't know how to do number 13. Look at my answer guide and see if you can come up with stuff that kind of stuck you. Why did I do this? All right, that's a good question to have. Why did you calculate this little part right here? Or how did you calculate this big part right here? A lot better question than just, how do I do number 13? All right? All right, guys, the rest of the time is going to be for you to work.
What's the exact form?